Okay, you guys, this is the chapter Unit 2, Force and Momentum vocabulary. Let's go ahead. It's going to kind of go out of order, but that's okay though. We're going to start with force. Force is measured in N, which is Newton for Isaac Newton's. So the international unit for force is into the Newton. And basically all a force is something that is a push or pull that causes a change in motion. That means a change in velocity. That means a change in velocity. Okay, and there are two types. We have the contact forces and the field forces. Contact are things that touch to do their push or pull, and field forces, they do not need to physically touch. This is action at a distance. Act at a distance. Okay? And one of the forces we're going to learn about this chapter, force gravitational, would be a field force, right? But pushing and pulling physically with your hands would be contact. And we're going to learn some contact forces in a second. All right. Let's go up to a specific type of force that we're going to learn about called force centripetal or centripetal force. And the symbol for that is F subscript C, FC. Centripetal means center seeking. Of course, force is force. That just means a push or pull that pulls an object into a circular motion. And in particular, that push or pull is towards the center of the circle. Okay, so the push or pull is going towards the center of the circle. And let me show you some examples of that. All right, so an object may be wanting to go in a straight line, but then something like a rope or a string pulls it towards the center, and then the resultant of that ends up being this circular path, right? So you got things like gravity. The Earth wants to go in a straight line, but the sun pulls it towards the center, and you end up getting a circular, actually an elliptical motion. Let me show you some other examples here, because there are lots of different types of forces, right? So when we look at something like airplanes that are bending their wings and vectoring their wings around, right? They're using air resistance. They're using the force of drag from the air resistance to vector themselves into the center of the circle. You see that? So wherever they're at, they end up pointing to the center of this curved path, right? So this would be the force centripetal being supplied in that. Okay, interesting. All right, let's see. We also have, if you're driving on the road, right, and you decide to turn the wheels of your car, the wheels are supplying force friction to the center, so the force friction is going to be the force centripetal. All right, we're going to talk about friction in just a second. Okay, here's another one. So here is a really interesting way to mow your lawn. The lawnmower wants to go in a straight path this way, but the string is pulling towards the center, and you end up getting this nice circular path, right? A nice circular path. And then, of course, the force we're going to learn about and that you're really familiar with is the force employed by carnival rides or a washing machine called force normal. Okay? So without these walls here, your body would fly off in a tangent line to the circle, So you fly off that way or that way. These people would fly off. This guy right here would fly off this direction if the wall were to disappear suddenly. This guy would fly off in a straight line this way. This guy would fly off in a straight line this way. But because the walls are pushing towards the center, all these people end up moving in a circular motion. Okay, that's the outcome of a tangential speed opposed by a center-seeking force centripetal. Okay, so those are a few ways to find force centripetal. All right, moving on. We're going to kind of move along a little bit. Remember, you can pause this if you need to. Now, a really big part of the equation of force is this term we've learned about before, inertia, which is a tendency of an object to resist change in motion. This is based on the amount of mass the object has. The more mass, the more inertia you have. All right, so look at, here is one half of the coin of Newton's first law of motion, of inertia. An object in motion wants to stay in motion, so you see that the block here was moving with the car, and when the car comes to a sudden stop, that doesn't mean this mass is going to stop, right? So it's going to slide off, right? And that's why it's continuing to go forward, because it's not going to want to change its motion for no reason. Okay, let's go back. We kind of teased this in a little bit with friction, right? F sub F, since it's a force, it's also measured in newtons. Make sure you write these little extra notes here. All right. Now, friction in general is a force that resists sliding motion between two surfaces, and it is a contact force because guess what? It is physically touching. You have two types of friction. You have static, which means non-moving. So it's the force that allows objects on the ground to stay in place, right? Stay in place. You notice when you try to push something, it resists you a little bit. That's the force of static friction, right? But once you get that object moving, you have the second type of friction called kinetic or moving. Kinetic is means motion, right? So check this out. When you get something actually going, this is your applied force, so you apply this way, but you have a little bit of drag from the ground coming back at you, right? Okay, so that's the kinetic friction. Okay, so there's the difference between the two. And there's when you get to physics later on, we'll talk about which one is higher and why. Okay. All right. Next, let's talk about gravity. Okay, gravity in general, not the force gravitational, but the idea of gravity is basically just an attractive force that acts on any object with mass. Okay, it is a field force because it acts at a distance. It does not need to touch. Right. The Earth will pull the moon towards it without having to have a string attached to it. Any object with mass has a gravitational field, so you have a gravitational field to the person next to you. So even if that guy or girl doesn't like you, guess what? They're attracted to you. Okay, check this out. And the force gravitational of Earth, or the gravitational field, is going to decrease the further you get away. It's actually decreasing by a factor of a square. Okay, so that's pretty interesting. It's inverse square law. So if I were to be, inverse square law, right? If I were 2 times further away, that would be a 2 squared. So guess what? Force gravitational was only a fourth of what it was before. Now, you don't need to worry about that too much, but I thought, just in case you were wondering how gravity works, that's how it works. Okay. Next, let's see. Let's move on to air resistance. So we talked about that with the airplane earlier. Objects only, that's free fall. All right, where is air resistance? Here we go. Okay, air resistance is a friction-like force that objects falling through atmospheres experience, right? It's also called drag force. This is a force that's measured in newtons. It changes based on the size and shape of an object. The size and shape of an object. All right, let's see. So I'm going to go over this one, and we're going to take a pause here, and you can watch the second half of this in just a second. Okay, so let's compare feather falling and these billiard balls falling, right? So the feather is going to fall, and it'll kind of go to the ground a little bit slow. The billiard ball, based on its shape, it's nice and smooth. It doesn't have a lot of surface area to let air kind of interact with it. It's going to fall pretty rapidly and accelerate rapidly. Okay, so these are some of the forces that we're talking about. I'm going to go ahead and make a second part to this, so that way this video isn't too clunky and long.